Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syazana, Adilah Binti Zulkifli. I would like to present my project entitled Carbon Nanoparticles Modified Chemlock Adhesive System for Natural Rubber Aluminum Alloy Bonding in Automotive Application. So briefly, this is my project about which is graphene as carbon nanoparticles filler in the adhesive as the graphene nanoplatelet or GNP has a good higher surface area and good thermal conductivity that will insert into the Chemlock adhesive to bond between natural rubber and aluminum alloy. So the Chemlock adhesive is preferable in industrial. Thermoset adhesive good and stronger bonding. So the adhesive bonding that led the molecular interaction between the two different materials. The example of the metal rubber parts is in automotive application, a rubber engine mount. That this rubber engine mount acts as to absorb or to dampen the oscillation, noise and vibration. So next part is the problem statement. So I love to highlight this part as the problem statement linked to the solutions. So firstly, the recent automotive demand from the consumers. The latest demands in the automotive for better performance, for better consumers, for better safety, stated by Binti et al. 2018. So one of the example of vehicle parts is rubber engine mount that uses to reduce noise and vibration. Secondly, the significant use of lightweight in the vehicle components. The utilization of aluminum alloy may reduce the load transfer and better fuel consumption. Thirdly, current system is providing insufficient bonding between natural rubber and aluminum alloy. Therefore, the study to develop new adhesive system between these both materials is critical. Next, the limited study adhesive system as Chemlock used in industries. So generally, I would like to refer to previous study from epoxy adhesive. And next is industrial problems due to VOC emission of primer usage. To promoting greater bonding is not only the primer usage, we also use the GNP adhesive to form nano adhesive. Next part is objective and scope. The objective of the study have four, which is to prepare the modified Chemlock adhesive by ultrasonication method. Secondly, to evaluate bonding strength of the adhesive by using the pill test. Thirdly, to correlate natural aluminum alloy bonding strength with morphological by SEM, structural by XRD, and thermal properties by DSC. Last but not least, to synthesize the effect of primer in modified Chemlock adhesive. So the scope of study divided into rubber materials, raw materials, natural rubber, aluminum alloy, Chemlock 205220. Then the metallurgy part, which is divided into the preparation samples and the vulcanization process, which is used hot press compression. And lastly, the testing that involves the mechanical test, morphological by SM, thermal analysis by the SC, and structural by XRD. Next, the literature review. I will compress the literature review into the 6 main parts. Automotive application, a rubber compound, aluminum alloy, rubber metal bonding adhesive system, and graphene nanoplatelets. So the automotive application, as stated, the demand in automotive need is something that greater performance, greater cohesiveness. So engine mount is one of the part in vehicle that fulfill and satisfy the demand by remove and the unwanted vibration level. It's stated by Salim. Then use the lightweight materials. So the positive lightweight gives better performance as is reduce the load transfer and better fuel consumption. Next is the example of the lightweight that used is combination between rubber compound and aluminum alloy. the rubber compound has superior level of damping properties is used to create the mounting and suspension. So next, the rubber not work alone is combined and linked with the combination with the aluminum alloy. The aluminum alloy chosen as light and quick corrosion resistant by Mafungwa et al. 2017 state that steel is better absorption impact energy in crash or accident. So Herman jump into conclusion to prefer aluminum better than steel as the steel is heavy. So the aluminum alloy and natural rubber will combine by the rubber metal bonding. So the example is the engine mount itself, because the good combination create the unique properties with rubber flexibility and metal stability, like UH et al. 2012 state. So the use to join these two different parts by using adhesive system. So adhesive system is preferable than mechanical fastening because the benefits it shows better. Okay, and it play important roles in car. Next, the adhesive also work alone as to increase the bonding strength between these two different parts. The GNP will insert into this adhesive system because the GNP has higher surface create the super interaction between the molecules in the bonding. So the effect of nano composite adhesive system proved in the Georgie Babu et al. 2020. Next, the methodology part. Okay, this is my overview of the flow chart, which is firstly aluminum surface preparation that use sandblasting to roughen the surface, and this roughen surface to allow the mechanical interlock between the adhesive and the adherents. Next is step 2, GNP preparation by ultrasonic path. Okay, this is to function to agitate GNP nanoparticles. This is graphene that layer, step by layer, but then it will disperse if agitated at proper times and temperature. Next is step 3, adhesive preparation. Insert the GNP in the Chemlock 220. Then swap the first layer Chemlock 205 as primer. Then swap 3 layer modified Chemlock 220. Okay, next, this modifier will achieve the objective 1. After the sample is prepared, we'll recognize the parts by hot press with the STM3429. Then, after the sample has completed, we will undergo the field test for strong mechanical testing and to correlate between these materials to achieve objective 3. Okay, this is the design of experiment. Basically, it has 8 samples, which is GNP0 as a controller and different weight percentage of GNP 0.5, 3, and 7. So this is a ratio that we will use 3 to 0 for the first 4 samples and 3 to 1 layer ratio to the 4 other samples. Okay, next, the method for objective 1 to prepare modified Chemlock adhesive. So by ultrasonication, this is put in the ethanol and the beaker, then proceed to hot press compression at under 40 degrees C at 10 minutes before make the field test to achieve the objective 2. Okay, the method to objective 3 considers SRD to identify the phase peak, the ADSC to achieve the thermal analysis, which is TG glass transition temperature and melting point, and next is SEM for the fracture surface for the both surface. The expected result shows that the increasing GNP shows the increasing maximum field force, show the GNP interaction, but the lower reinforcing effect once solution level is reached. It show the GNP agglomeration. So this is the rubber parts dimension, aluminium, and adhesive. With that, thank you.